the complex number homework with the Argand diagrams, the first thing we're going to do is put these points on the Argand diagram. So 2, let's put 2 here, shall we? 2 plus 2 root 3i. The first one's going to go up there. So there's Z1. And the next one is 2 minus 3i. So 2 minus 3i is going to go a bit further down there. So there's Z2. And then minus 1 plus I is going to be there. So there's Z3. I've tried to draw that one at sort of 45 degrees because I can tell it's going up like that. So there they are on the Argand diagram. And the next thing we're going to do is find the length of them. So the length of Z1 is sort of using Pythagoras. So I've got 2 squared and 2 root 3 squared square rooted. So what's that? That's 4. And you know what this is? That's 12. That's 16. So the length of that one's 4. I can repeat that for the other ones. But rather than repeat that again, let's just show you how you would do that on the calculator. So we can go to options, complex numbers, and I want the absolute value of. And so what was the second one? The second one was 2 minus 3i. And so it tells us the next one. So the modulus of number 2 was root 13. So you could do that for any of them, really. I'll do Z3 in a second, but part C says find the argument of these things as well. So the argument, that's this angle here then. And so we know that that distance there was 2 root 3. And we know that that distance there was 2. And so the argument of Z1 is the inverse tan of 2 root 3 over 2. So I'll grab our calculator. I think I'm already in radians mode. So we'll do the inverse tan of, what do I say, 2 root 3 over 2. And it tells me that the answer here is, so the argument of Z1 is 1/3 pi. But, again, I could repeat this for lots of them. I mean, Z2 here, clearly it's going to be negative going down here. But look, we can do this on the calculator. We have an argument. The argument of, what's the second one? 2 minus 3i. The argument of that is, oh, that's a shame. I was hoping it was going to be a nice number, but it's not. So the argument of Z2 is minus 0.98. And I think I'll do another digit there, 983. And again, I say I'll show you Z3 in a second. Hence, write them in modulus argument form. So Z1, we've said, was root 13. So it's root 13 cos the angle plus I sine the angle. And Z2, which we did before, it wasn't root 13, that one was it was 4. And Z2 is root 13 cos of minus 0.983 plus I sine of minus 0.983. Now I've left Z3 on purpose because I want to show you Z3 just totally on the calculator. So Z3 is minus 1 plus I. And if I put minus 1 plus I in the calculator, and I'm still in this complex number mode, but I actually have a button here that says just change it into its modulus argument form. And it tells me straight away that the modulus of Z3 was root 2. The argument of Z3 is 3/4 pi, and that means I could go straight to Z3 equals root 2 cos 3/4 pi plus I sine 3/4 pi. And I can do it all on that one button, and there's lots of times that is quite useful to go straight to that button there. Some people are a bit lazy. This is the modulus argument form. If you wrote and the answer, like the calculator says, that's the calculator notation for it. No, you won't get any marks for writing that. That is the calculator's way of showing that bit there. So a long video there, hopefully talking it through.